Guys, today I'm going to go over how to solve some rational equations. The reason it's called rational is that the things on one side, usually both sides, involve fractions with variables in the denominator. Now, usually the way that you solve these is that you multiply by the least common multiple of the denominators. But in case that might be confusing, I'm not a huge stickler for terminology and all the fancy names for things. I'm going to say instead, if you don't want to talk about it that way, multiply by the smallest thing that makes all the bottoms go away. Because if the bottoms go away, then we're not dealing with fractions anymore, and you'll be able to solve the equation using normal methods. Okay, so I've started you out with one that's similar to a question that I got, and that is this one. The question is, what do I multiply by? I want to multiply the equation on both sides by something that will cause all of the denominators to go away, and that way I'm not dealing with fractions anymore, and the question becomes easier. So to look at this, I can list the denominators. You don't have to write everything out like this every time. I'm just showing you with a lot of detail. The denominators are 5x, that's from right there, x, that's from right there. And then you might say the third thing in this equation doesn't have a denominator. Well, just so that it can have a denominator, I'll say that it has a denominator of 1. Because after all, something that doesn't have a denominator can be written over 1, and that turns it into a fraction, quote unquote. Okay. So I need something that all three of these things go into so that when I multiply by that thing, it will cancel for all of them. It turns out that in this case, the thing I can multiply by is itself 5x. Because think about when I multiply by 5x. These red brackets here mean that I'm multiplying every part of the equation by the 5x. So everything on the left is getting times by 5x, and everything on the right is getting times by 5x. When I multiply by the first term in the equation, the 5x will cancel in its entirety. Okay, so that causes that bottom to go away. When I multiply by the first term on the right-hand side, the second term in the equation, the x here goes away and the x goes away, meaning that I will end up multiplying by 5. And now the final term, well, we all know that this is, kind of a fake fraction in the first place. So there's nothing to cancel there. They just multiply directly. Let's go and actually do this. So we do the multiplications one term at a time. The first term, that means I'm going to be doing this multiplied by 5x. That's going to be simply x minus 4. Because like we said, the 5x and the 5x cancel. Okay, now I'm going to multiply this term by this. Well, in this, like we said, the x and the x cancel, leaving multiplication by 5. So this will be 1 on the top times the 5 that remains. It might seem weird that I'm writing it like that, but when we get to more complicated problems, it'll make sense to keep track of things like that. For the 1 multiplying by the 5x, there's nothing to cancel, so I'm going to just write 1 times 5x. This should, at this point, be a very familiar type of equation for you. First, I'm going to take the right-hand side and expand it, get rid of all the parentheses. 1 times 5, of course, is 5. And then 1 times 5x is 5x. I'm going to rearrange everything so that the variables are on one side and the constants are on the other side. That means subtract 5x from both sides and add 4 to both sides, leaving me with negative 4x equals 9. I can divide by negative 4. to get that x equals -9/4. Now, in these rational equation solutions, you always have to be on the lookout for whether you are mistakenly claiming that one of the restricted values or off limits values in the original is being proposed as a solution. So what was off limits? This always goes back to the original equation. The off limits values are determined by what was on the bottoms of these equations. So the 5x is on the bottom. It cannot be equal to 0, because if it is, then that means that we are dividing by 0, which is against the law. So we can't have 5x be equal to 0. But that means that x can't be equal to 0, because the only way that 5x can be equal to 0 is if x is equal to 0. So x can't be equal to 0. And if we find that as a solution at the end of all this, then that means that it's like disqualified. We didn't make any mistakes, but we have to admit that it's not a real solution. So that's based on this bottom, the 5x. It turns out that the next bottom, the x, actually gives us the very same restriction, because the thing that would cause that bottom to be 0 is precisely the same value, x equals 0. So now we know that x equals 0 is the only off limits value. Because -9/4 is not 0, that means that we're good. We didn't find the off limits value. So this is the actual solution to it, -9/4. Let's do one that's a little more complicated. The first step is going to be the same sort of thing as before, except that now I want to do a little bit of bookkeeping in the middle, because this term right here, this is extremely suspicious. Why on earth would I have a linear term in the first and the third, but then in the middle term there, now I've got a quadratic? Well, here, the thing that we want to do is actually factor that to find the thing that will multiply to cancel all of the bottoms. So I'll say n squared minus 7n plus 10. I'm going to factor that, and I get n. If you like, you can draw a box to do this. Let's see, n squared and 10. That means this must be n and n. And then let's see, if we do -2 and -5, then this will be -2n, -5n, and these mix to get a -7n. So I know that this will be n minus 2 times n minus 5. I'm going to replace the quadratic in the original with this factorization, because that is going to make it clear what I need to multiply by. Okay, so now that I've done that factoring, I'm cleaning up the work just because I have limited space, but hopefully you're writing on a bigger piece of paper. You don't need to do that. What can I multiply by that will get rid of the bottoms of all of these things? Well, look at the bottom here. N minus 2 shows up again here and again here. So whatever I multiply by, it has to include the n minus 2 to get rid of this entire bottom, and this part of that bottom. Okay? Now, I also need to multiply by n minus 5. You can see why, because although it doesn't affect this, no effect on that, it also doesn't affect this. I need to get rid of all of the bottoms with a single multiplication, and the only way to do that is to multiply by the n minus 5 as well. So the thing I need to multiply by is n minus 2 times n minus 5. Just like before, I'm going to be multiplying both sides of the equation by this, and I'll look at what cancels and what remains with each one. In the first multiplication, the n minus 2 and the n minus 2 cancel. So what remains with the first multiplication is 1 times n minus 5. This plus sign is this plus sign. You have to make sure that you're keeping a good account of the different pieces. So now for this term multiplied by here, well, look at the n minus 2 and the n minus 5. It's on the top and it's on the bottom in both pieces. So that actually will go away entirely, and we'll just have the 1 left over from the top. The final multiplication will be the 6 over n minus 2 I'm going to multiply this, but the n minus 2 will cancel here just like it canceled in the beginning. Okay, so I'm going to get 6 times n minus 5. See how the n minus 2 has disappeared, and now we only have the n minus 5 to deal with. Just like before, this is a linear equation. I'm going to remove all the parentheses. N minus 5 plus 1 equals 6n minus 30. Now, variables on one side, numbers on the other, minus 6n, minus 6n. Negative 5 plus 1 is negative 4. So I'll add 4 to this and add 4 to this. And the result of that will be that I get negative 5n on the left-hand side. All of these have gone away. And negative 26 on the right-hand side. Divide by negative 5, and I get negative divided by a negative is a positive, and n equals 26 over 5. Remember that at the end of this, you should do a quick check to make sure that you didn't, by mistake, give one of the off-limits values. So off-limits here. This is going to be the things that could make the denominators in the original equation equal to 0. But you can see it's very easy. This, the n minus 2, that means that n can't be 2, because if n were 2, then we'd be dividing by 0. So n equals 2 is off limits. You can probably see where the other off limits value is. I'll give you a second to look for it. Yes, you're right. It's right here in the n minus 5. Because of that factor, n cannot be 5. Because 26 over 5 is neither of those numbers, it's a totally legitimate solution. So, like this video? Want more help with your homework? I am available for appointments with students at this number, 617-966-3198. You can also visit my website at sntutoring.com, where we can set up an appointment either in person here in Needham or online via Zoom. Have a great day.